Welcome to this presentation on one-dimensional arrays. A one-dimensional array or one-day array is a data structure used in programming to store a collection of elements of the same data type in a contiguous block of memory. It is the simplest form of an array, where elements are accessed using a single index. The key features of a one-day array are the following. Number 1, homogeneous elements. An array is a collection of elements stored in a contiguous memory locations. However, all elements in the array must be of the same data type, whether integers, floats, or characters. In this example, the array numbers store 5 integers since all elements are of the same type, which is integer. This is correct. Now let's check an incorrect array declaration. So C expects all elements to match the declared data type, which is an integer. Here, we have a float, a character, and a string, which causes a compilation error. So the second feature of a one-day array is fixed size. The size of an array is determined at the time of declaration and cannot be changed later. If you declare an array with 5 elements, it will always have space for exactly 5 elements. So in this example, we declare an integer array with a fixed size of 5. Once declared, the size cannot be modified dynamically. We have here an example of a correct usage of an array, wherein we declare an array size of 5. In this example, this is an incorrect usage. This will result in error because the data type is not declared properly. You need to specify the data type such as integer, float, character, or string. Now, the third key feature of a one-day array is index access. Every element in an array has a unique index starting from 0. In an array, each element is stored in a specific position identified by an index. The first element is at index 0, the second at the index 1, and so on, up to size -1. We use square brackets with an index number to access an element. Accessing an index beyond the array size or out of bounds leads to undefined behavior. So let's now proceed with the declaration or a code to define an array. So this line includes a standard input-output library or stdio, which allows the use of printf function to display output. So we have an int main, and then the declaration and initialization of a one-dimensional array named numbers with 5 integer elements. The size of an array is 5. The elements are 10, 20, 30, 40, and 50. The array indices range from 0 to 4 since indexing starts from 0. This line prints the first element of the array. Number index 0 refers to the first element, which is 10, because arrays in C use zero-based indexing. So this line prints the third element of the array. Number index 2 refers to the third element, which is 30 since indexing starts from 0. So the return 0 statement indicates that the program executed successfully. So the expected output would be first element, which is 10, and then the third element, 30. Now, the fourth key feature of one-day array is efficient memory usage. All elements are stored one after another in memory. This allows fast access to elements using indexing and better cache performance. Since arrays store elements in contiguous memory, accessing them via indexing is very fast compared to linked list. We have here an example of memory representation of int numbers with size 5 with the elements 10, 20, 30, 40, and 50. So this is how it is being positioned in our memory. So if an int takes 4 bytes, the memory locations are assigned sequentially. Accessing numbers index 2, which contains 30, is fast because the address is calculated as base address plus index times size of each element. So we have here the base index is 1000 and the index is 2, and then the size of each element, which is an integer, is 4 bytes. Therefore, 2 times 4 is 8 plus 1000, 1008 is our memory location. In this demonstration, we explored the key features of arrays, how they store homogeneous elements, provide fixed size storage, enable index access, and other efficient memory usage. Arrays are a fundamental part of programming, allowing us to handle multiple values with ease. By mastering array operations like initialization, traversal, and modification, you'll be better equipped to manage and process data efficiently in your programs.